All right, today's lesson, I'm out today. So today's lesson is we're continuing proportional relationships. We have looked at identifying a proportional relationship. We have looked at it from tables and charts, identifying proportional relationships and writing an equation. So today, we're still going to identify the rate of change and write an equation, but today we're going to be looking more specifically at graphs. All right? So you should have your notes in front of you. So as you go along with the video, there will be times when I tell you to pause the video and try something. I would like for you to make sure that you are doing that, pausing when I ask you to pause. So first thing, at the top of your notes, this is the notes. You're just going to do your warm-up right here. Just take a couple of, you're going to write just a couple of them. So what I would like for you to do is to write an equation for each of these situations. Remember to find my rate of change, or the COP. That is simply your y over your x value. That's how you find it, your y over your x value. When you want to write an equation, then your equation should be in the form of y equals kx. That should be the form in which you write your equation. Okay, so pause the video and put those up at the top of your notes page. Take some time, pause the video. All right, so check your answers. All right. So one of the things you need to make sure that if you can write the equation, that's awesome. But you also need to know what the equation means. So in this case, y equals 2x. So that means every time whatever x is, I'm always multiplying it by 2 in order to get the y value. So you can always use that equation to help you find numbers that are not listed here. Let's say I had 18 pieces of chicken. 18 pieces of chicken. How much would it cost me? Well, 18. If I plugged in 18 here, 2 times 18, that would give me, it would cost me $36. Okay? Down here, this means 16 times x. So my boxes of candy, however many boxes of candy I have, if I multiply it by 6, it's going to give me how many pieces are there. So you have to understand what the equation means. All right? Okay, so let's go through a couple of this vocabulary, and then we're going to move on to the graphs. All right. So proportional graphs always pass through the origin, or 0, 0. Down here, if you remember that first video we watched, it always has to start at 0, 0. If it doesn't, then it is not proportional. It's not proportional. Okay. So make sure to write that down. The rate of change, or the constant of proportionality, those are the same things. I'll kind of use both of them. Okay, can be found from a graph by finding an ordered pair and finding the ratio of the y over x. The y over x. So again, we're going to write all this down and then we'll do some of them. The equation to represent proportional relationship is, again, y equals kx, where k is the rate of change, or the constant of proportionality. Okay. So now we've used this as many times. We've called it k, we've called it the scale factor, we've called it unit rate, we've called it the constant proportionality, now the rate of change. And then when you get into 8th grade, it will be slope. So all of them mean the exact same thing. It is a relationship of your y value over your x value. It is a relationship. All right, so let's do some examples here. All right, so the graph shows the rate of change that a monarch butterfly is traveling during migration. Okay, it's very important that you look at the titles of the graph. You look at the titles of the graph. So if you look at the titles here, my x values represent the time. My y values represent my miles. So the first thing I need to do is find some points on the graph here. So when you find points on the graph, you want to make sure that it is an intersection of the x and y. So you're not just going to find one like right there. That's not going to work because it's not in where they intersect, the x and the y. So you want to look at the places where they intersect. Let me get rid of that point. Okay, so where they intersect is here, 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 and here. Oh, there. And it would keep going because it's a straight line. Okay. So I'm going to find a couple of points on the graph. So I'm going to make a little chart right here because I've got plenty of room. Okay. You can do that too. Make a chart. So I'm giving you time. Make a chart because I'm going to look at these notes. So let's just choose a couple points. So we're going to go over 1 up to 5. So that would be 1, 5. Let's just do 2 other. I'm just going to choose this one here. So I'm going to go over to 4, up to 20, 4 to 20. Let's just choose one more. Let's go this one right here. All right, so I go over to 7, up to 35, 7 to 35. Okay, so let's first just make sure it is a proportional. So I am multiplying by 5, or my y over x is 5 over 1. This one would be 20 over 4, which is still 5. This is still 5. Okay, so that works out. So my rate of change is simply 5. The k equals 5. Then my equation, remember, it needs to be in the form of y equals kx. That's just going to be y equals 5x. Okay? All right, let's try the next one. So now they are having you make a graph. They're having you make a graph. So let's look at it. Maria is baking chocolate chip cookies. Each cookie has 9 chocolate chips in them. Create a graph that represents the situation and find the rate of change. So let's first make a little chart here. Okay, so my x value, well, look down here. This is my x-axis. So my x value is going to be my cookies. So this is the cookies. Oh, if I spelled cookie right, cookies. Let me spell that right, cookies. And then my y value is chocolate chips. So let's think about it. If there were no cookies, there would be no chocolate chips. So that's 0, 0. It has to start at the origin. Okay. If I had 1 cookie, that would be 9 chocolate chips. 1 cookie, 9 chocolate chips. If I had 2 cookies, that would be 18 chocolate chips. 3 cookies times 9 would be 27, and so on. Hopefully you see the pattern here. 4 cookies would be 36. 5, you continue it out for me. Figure out what it would be. Okay. So then the rate of change, anytime they give you 1 to something, that's automatically your rate of change or your unit rate, which we have talked about. Unit rate. Unit rate is the same thing as your rate of change. So your rate of change is 9. So my equation is simply y equals 9x. 9x. All right, will you pause the video? And I want you to do number 3 by yourself. Do number 3 by yourself, pause the video, and come back when you have all of 3 completed. Remember, this is integrity. If I say pause the video and do it, that's what I would like for you to do. All right, let's check your work so far. So your rate of change would have been 12. That's just your y over your x. So that's 12. Equation y equals 12x. So what does the point 560 mean? Well, this is your x value. This is your y value. So 5 means your tickets sold. So 5 tickets. And your y is your cost. So costs $60. All right. That's what that means. So however many, whatever your x value is, the y value is how much it would cost. Okay. Is this a proportional relationship? Yes, you should know it for a couple things. It has to. So it has to start at 0, 0. So it has to start at 0, 0. That's a check. Okay. It has to have a straight line. Has to be a straight line. That's a check. Okay. There can't be any wiggles anywhere in there. It has to be a straight line. Okay. And you have to have a constant rate of change. You have to have a constant rate of change. Okay, that checks. Everything is multiplying by 12. It's always k equals 12. So those are the three things that you have to have in order for it to be proportional. Okay? All right, so let's look at the next one. So a pitcher for lemonade is being filled with water at a rate of 1/3 cup per second. Which graph represents a constant rate of change at which the pitcher is filled? All right, I want you to pause the video and see if you can figure that out. Pause the video and see if you can figure that out. All right, so let's check these out. Well, first of all, it says which graph represents a constant rate of change. Constant rate. Well, I can go back up here, first of all. They all are straight lines, so they do fit that one. 0, 0. This one, I don't even have to look at this one. It doesn't start at 0, 0. So that won't work. This one, no way. It doesn't start at 0, 0. So I can already eliminate those. So now I just have to look at 1/3 per second. So that means for every second, my y value should be at a third. So for 1 second, my y should be at a third, not 3. It should be at a third. So 1 second, yep, that one looks pretty good. That should be a third. Okay? This is 3, not a third. Okay? Okay. Let's keep going. All right, I would like for you to finish 4 and 5 by yourself and come back when you have those completed. Do not come back until they are completed. So pause the video and come back when you have it completed. All right, let's take a look at 4 real quick. So if you looked at these, hopefully this was pretty easy for you. Okay, a couple things over here. None of these are really on the intersection of a y and an x value except for your 5, 6. So when you graph this, you can get a ruler or something. You need to make sure and start here. These are going to kind of be, you're going to do your best with this, but you need to make sure for sure that your line goes through that 560, because that one was an easy point that you could make. The other ones were kind of, so it looks like, see, my 224, oh, see, I can even see what was wrong with my 224. I totally had that wrong. So I'm going to fix that one after I finish my line. So let me go back over here. This was not right. Let me get, that one was not right. It should have been 224, which is right here. Okay, so that one is wrong. So I can tell that it was messed up by my graph there. Okay, the other thing that they did not do, which they should have, is you should always label your graph. You should always label your axis. So my x value is my boxes. So number of boxes, number of boxes. My y value is the number of bandages. Okay, that should be graphed. All right. All right, 5 and 5. Let's see. What does 0, 0 represent? It means, let's see. I got to look at the relationship. The plowing cornfields. So if he doesn't plow, plow. So no hours plowing means no corn. No corn. Okay. If he doesn't plow, so no hours plowing, no corn. Right. Choose an ordered pair to find the constant of proportionality. Okay, so we know this is a constant, so I can choose any point on the line. The tricky part is, what point do you choose? Well, I'm not going to choose something here because that is not directly on the intersection of y and my x value. So this one is not on the line there. You cannot choose that one. So look for one that is directly. That one is directly on. See, are there any more? This one is directly on. So those are the only 2 points that I can really use. So this one is 8, 120. So I went over 8 and I went up to 120. This one is 460 over 4 up to 60. So I'm going to use this one because this one is easier. So my y value over my x value. So that is 60 over 4. So if I divide that, 4, that is 50. So my constant is 15. I said 50. 15. Okay. So then I'm going to write my equation. Y equals 15x. Okay. Okay. All right, last two. Go ahead and pause your video and do those last two. Pause the video. Come back when you have it completed. All right. Well, if I look at this one, I'm going to choose a point on here to get my rate of change first. So I'm going to try this one. Yep, that one looks pretty. Oh, actually, I'm going to try this one. That one's easier. So this is 410. So my rate of change is 10 over 4, which equals divide by 5 over 2, which is 2.5. So that would be my equation. So that means for every hour of time, I'm going to multiply by 250. So for 10 hours, 10 times 250, would that be $4? Nope, that would not equal $4. So that's a no. 8 hours for $20. So if I plug in my 8 hours, so 8 times 250, yes, that equals $20. So that is true. And the graph will contain the point 1230. Well, if this is again is my x value, I would multiply 12 times 2.5. Yes, that does equal 30. So that one is true as well. Okay. Last one. And sketch a graph to represent the relationship between those three. Okay, I'm going to sketch my graph and come back. All right, so there is your graph. Make sure if they give you an empty graph, you must label those axes. You must label what the x is. You must label what the y is. It told you x is the group. It told you that right there. X is the group, and it said y is your counters. It said that. Okay? All right, that is your lesson for today. Do not lose these notes. I might want to check it next time. You have an assignment, a class kick assignment, and you might have a Desmos too. So check with the sub, and I will see you next time. If you have any questions, let me know. Have a great day.